Okay, rationalizing the denominator. What we mean here is just basically how we leave our answer. Now, when we're leaving our answer, we have to make sure that any perfect square other than 1 is taken out from underneath the radical. And there cannot be a radical left in our denominator. So I'm going to explain what I mean by that as we walk through this problem. Now, as I break this up into square root 25 over square root 3. Okay, square root 25 we can take, and it becomes 5. Square root of 3 I can't take, so it stays in the denominator. So what we're going to say here is it's very easy to divide by a rational number. Okay, if this was a 3, it's very easy to take a value and break it up into 3 equal groups. It's very difficult to take a value and break it up into square root of 3 equal groups. So what we like to do is I'm just going to leave my answer. I don't care if there's a radical in the numerator, but I cannot have a radical in the denominator. So what I want to do is multiply this fraction by something that's equivalent to 1, okay? That's going to change the way it looks, but not its value. So here, in order to get rid of this radical, I'm going to multiply it by another 3, another square root 3. I'm also going to multiply the numerator because root 3 over root 3 is 1. Okay, so now my numerator becomes 5 root 3. My denominator, root 3 times root 3, is root 9. And the square root of 9 is rational 3. And my goal is I want to be able to end with an integer, a rational value in the denominator. Okay, I don't care if there's a radical in the numerator. We just want to rationalize the denominator. Okay, so 5 square root 3 over 3 is going to be our simplified answer. Okay, now we're looking at this. We've got the rational number 25. Notice it's not under a square root, but there is a square root in the denominator. Okay, now this would be the end of a problem, and then I just take the last step to rationalize the denominator. I don't want to leave this radical here, so I'm going to multiply by something that's equivalent to 1. Multiplying by 1 might change the way it looks, but won't change its value. 1 times anything is itself. So now my numerator is going to become 25 root 5. Okay, root 5 times root 5 is root 25, and the square root of 25 is 5. So now it's rationalized, but it's not simplified. Now we do have a rational 5 here and a rational 25 here. These can cancel and reduce to 5 and 1. 25 divided by 5 is going to be 5. So this is now going to simplify to 5 square root 5. Okay. All right, let's continue. All right, now I've got square root of 3/8. Square root of 3/8 is, can't take. Actually, I can break it down. Actually, I'm not going to here. All right, so I've got root 3 over root 8. Now, my goal, if I multiply it by another root 8, the number is going to be very big. I want to get this to the next perfect square. Okay, so if I multiply this by square root 2 and square root 2, well, guess what? I now have square root 6 over square root 16. Okay, square root of 6 I can't take, but the square root of 6 I can, and it's going to be 4. Now I no longer have a fraction underneath a radical, and I no longer have a radical in my denominator. Okay, all right, one last problem, and it looks like I'm going to have to rationalize and then reduce. I can already see that because both values are even, so they're going to have at least a common factor of 2. Okay, so 10 over root 2, okay, is this could be the end result of some other work, but I just can't leave this as an answer. So my last step is I'm going to rationalize it, and I need to get rid of the root 2 in the denominator. So I'm going to multiply something that's equivalent to 1. Multiplying anything by 1 won't change its value, but it will change the way it looks. So 10 times root 2 in my numerator is root 2. Root 2 times root 2 is root 4, and the square root of 4 is going to be 2. So now my denominator is rational, but now I have a rational in the numerator and a rational in the denominator, and these two can reduce. So I get 5 root 2. It would really be over 1, but we don't need to write anything over 1. So 5 root 2 would be our simplified answer.